Jai Hind everyone. My name is Anju Joon. I'm the assistant professor in IT department, and today we are going to understand a topic which is K-mean clustering in data analytics. So today I'm going to tell you about what is K-mean clustering and why we need it. So it is the topic of unit 4, in which we need to understand about the frequent items, means when we are dealing with the data stream, any kind of the data items where there can be the repetitions. So in that we always find the distinct elements. So that is the part of that we are finding out the frequent items. But we need to understand the item which is being repeated for a long time. It holds certain um, points that it need to be included in our concern. So this is where we need it. So what we will do basically, we will make the cluster of those items which exhibit same kind of the behavior or attributes. So we will club them, and in between of them we will find out how strongly they are connected. Why we need to find out the correlation between them? Correlation means what is the probability if one event is happening, so another will also be happened. So we call it association rule. Association rule says if there is a X set, so each element which is subset of X will also do this exhibit the same property as X is exhibiting. So this is we need to keep in mind. So here K-mean clustering will make the clusters of same behavior item. So let's see how it happens, and then we can find out the correlation between them, and it will be very easier as they are exhibiting same kind of nature. So let's see. So K-mean basically is an unsupervised clustering algorithm, and here we will make the clusters and we will represent it with the K, means if there is a so there is K tells you the number of cluster we need to find. So K's value will determine how many clusters will be there. If it is 2, means there will be 2 clusters, and if it's 3 or so on, so these are the number of clusters. And what we do basically, there will be a algorithm in which we will find out a centroid. So and from that centroid we will find the distance between other elements around that centroid, and those elements who are having less distance, they will come into this cluster. So how we will do it? First we will have some kind of the data set. Like here you can see there is a data that is 2, 4, 6, 8, 10, 12. So here what we need to do is, there is a K value which we can see here. It is saying K equals to 2, means we need to make 2 clusters. So what we will do, we will divide it into, as there are 6 elements, so 3 elements I will take into C1, which will be 2, 4, 6, and C2, which will be 8, 10, 12. So initially I have made these clusters. Okay, so these 2 clusters. Now what I need to do is, first we will choose the number of clusters. Here it is 2. Then we need to find out the centroid. So when we start making the cluster, we pick the centroid randomly. It can be anything, means it you can take 2, you can take 4, you can take 6, any element from the given data set here which we have located. So I'm taking 2. I will take 2 initially. I have taken this. I could have taken 4 or 6 also, but I'm going with 2 only. And same as I'm going here, let's take 10, not the first one element. So C2 I have taken 10. Now what we need to do is, we need to find out the distance. We will find out how much distance are there, means I will make a table which will be like this here. And what we will do, I'm talking about this one that we have assigned, and we will find out which one the centroid, okay, nearest to the. So initially C1 is 2, C2 is 10. Now when there is only one axis, single axis data like this, then it is quite easy that what you will do, how much distance is there between item and centroid. Like if I will go with this item 2, okay, so it will be C1 minus 2, this, that is our x1. So it is 2 minus 2, which will be 0. Same I will do with the second cluster also. 10 minus 2 will be 8. It will be in the mode, as we know the distance cannot be negative, so it will be in mode. So as we can see, the data item first x1 is nearer to C1. So in C1, the 2 element will go in this because the distance is less. Now we will go for the next. Here I will write down, okay, the C1 is being selected. Now I will same go with the this one. So C1 is 2 minus 4, it will be in the mode, so it will be 2. Same here, 10 minus 4, it will be 6. As we can see, again 2 is less than 6, so again this item will also go in C1. Same here, we will go for it. Here is the 6. So what I will do, 2 minus 6, it will be in the mode, it will be 4. Same, 10 minus 6 will be 4. Okay, so here I can see that there are, means both cluster have same distance with this particular item. So randomly we can put it anyone, but we need to make sure if it is nearer, means it was in the C1 and it is showing that it can be in the C1 and C2. So we will keep it in that cluster only where it belongs. As it is from the C1, so we will keep it in the C1 only because both are having same distance. If it belongs to C2, so we will put it into C2. So that means because it can be in both cluster, so we make sure that those elements who are not making any changes, so we will keep them where it was. So it will be in C1. We will take C1. Again, it will be 6 and 2. Here we can see C2. So C2 will be selected. Same 10. So it will be 8 and it will be 0. C2 will be selected. And here also 10 and here will be 2. So it will be C2. So are updated. Now I would like to go this previous one. What I have done, I have assigned each and every here, sorry. So I have taken this one, C1 and C2. Initially, I have made these two. So as we can see, again, we need to find out the centroid. I will show you. So how we will find the centroid? We will go here. Okay, in the C1, 2, 4 and 6. C2, it is 8, 10 and 12. We will take the mean of it. We will add them, means 2 plus 4 plus 6 divided by 3, which will be equivalent to 4. And here 18 and there 30 divided by 3 and it will be 10. So our cluster centroid updated is C1 is equals to 4 and C2 is equals to 10. These are the updated centroid. Now we need to check whether we have to go for another iteration or not. So here we can see C1 is holding 246, 246. Say there is no change. We will go for C2 cluster 2. It was having 8 and 12 and same is after the iteration, means there is no change in the cluster element. We can say that it is in a stable condition. So here these are the updated centroids. and these are updated, or we can say final clusters. Okay, we need to go for another iteration when the elements change its clusters. Okay, so now, yes, okay, so same as I would like to go here. So we have recompute the centroid. We need to go for 3 or 4 stages, but here as we can see there is no change, so we will not go further till the centroids or the assigned elements are stabilized. We will not go for another iterations. But when we do have more than one axis, we are talking about x and y, then we need to find out the distance between the element between two coordinates x and y. In that sense, we cannot use the simple one. We will find out the Euclidean distance. The formula will be like this: d square equals to x minus x1 ka whole square plus y minus y1 ka whole square. These x and y are the coordinate of centroid, which we will take for the cluster, and these x1 and y1 are the axis of the element, current item or element with which we are finding out the distance. So let's take the example of second. So here we can see there are 8 elements: A1, A2, A3, B1, B2, B3 and C1, C2. So here what we can see, here are 2 axes, x and y. Same thing we will do. We will check what is the value of k, and it is given 3. So we will make 3 clusters, which will be C1, C2 and C3. Here also we can go for the random element. I could have taken only 2 elements into it instead of taking 3, or I could have taken 1 element. It depends on initially what we want to take. We need to mention it in the copy. Yes, we are taking this. We are supposing these are the element in this cluster. So what I have done, these 3 means in the C1 I have taken A1, A2 and A3. In C2 I have taken B1, B2, B3, and in C3 I have taken C1 and C2 initially. And here what I have done, for the centroid I have taken the first element C1. In the C1 I have taken the centroid point is A1. In C2 I have taken B1, and in C3 I have taken C1. To the closest centroid, new centroid, we will recompute and repeat for the second iterations. So here we will go for the first iteration. Same thing I have done. Let's do. I am taking C1, which is 2, 10. I am taking C2, which is 5, 8, and C3, which is 1, 2. Okay. So here are the elements A1, A2, A3, B1, B2 and B3. Let's calculate the distance. C1 and this is x, y, this is x, y, x, y. And here is x1, y1, same here, okay. We know A1 is having the value of 2, 10, as we can see here also 2, 10. Same in the bold I have mentioned it. So how we will do? X minus x1 ka whole square means x is 2 minus this x1, it is also 2 whole square plus 10 minus 10 ka whole square, which is equivalent to 0. Okay. Now we will compute with C2. 5 minus 2 का whole square plus 8 minus 10 का whole square. So here 4 plus 9, it will be 13. Okay. Same with the C3 also we will find. It will be 1 minus 2 का whole square, 1 minus 2 का whole square plus I will go with 2 minus 10 का whole square, which will be equivalent to 65. As we can see, the smallest distance is between C1 and A1. So A1 will go in C1. In cluster C1, A1 will go. Let's do one more so that we can understand. For A2 also, now A2 value is 2, 5. As we will find out again, 2 minus 2 it is square plus 10 minus 5 ka whole square, which is equivalent to 25. Okay. With this C2, it will be 18, same formula, and here it will be 10. So, the smallest distance is between C3 and A2. So, A2 will go in C3. Same we will go for next element, which is A3. Here 8 minus 2, 8 is this one, or I can say 2 minus 8. When we are doing whole square, it will become positive. So it will be 8 minus 2 whole square plus 4, it will be 72. With C2 it will be 25. With C3 it will be 53. As we can see, with C2 the A3 is having smallest distance, so A3 will go in C2. Okay. Same we will go for it. As we can see, in C2 B1 is having smallest, so C2 B1 will go here. Okay. Same when I will compute all, so these will be the following clusters assigned. A1 will go in the C1 cluster. In C2 cluster, A3, B1, B2, B3 and C2 will go on basis of distance, minimum distance. In cluster 3, A2 and C1. Now we will compute centroid like the previous one. We need to compute this C new. As we can see, in C1 there is only A, so we don't need to find the mean because there is a single element and that will become the centroid. So C1 updated C1 is 2, 10. For the C2, as we can see, in C2 there are 1, 2, 3, 4, 5 elements. All x will be add, means 8 plus 5 plus 7 plus 6 plus 4. We will add them, it will be 30, and number of element is 5, divide by 5, it will be 6. Same, now we will go for y. 4 plus 8 plus 5 plus 4 plus 9, divide by 5, it will also 6. Now, updated C2 value is, centroid value is 6, 6. Again, we will go for C3. Here, as we can say, there are only two values, A2 and C1. So, we will add x, 1 plus 2 plus 1, 3. How many elements? 2. Divide by 2, it will be 1.5. Same, 5 plus 2, divide by 2, it will be 3.5. Same is here. So, these are updated. Now, as we can see, in C1, it is here we will go. As we can see, before it was in C1, I have taken A1, A2, A3, but in updated cluster, it is only A1. Means, now the cluster is being updated. It is not same as previous one. We need to go for another iterations. So, again, now we will put updated centroid as the value of x and y. And again, with every element, we need to find out the distance. Here, as we can see, when we are computing, A1 is having the less distance, the smallest. So, it will go in C1. A2 is having the smallest distance with your cluster 3. In cluster 3, the A2 will go. Same with the A3. A3 will go in cluster 2. Same with the B1, it will go in cluster 2, B2, cluster 2, and this. We will do it like this. And now, as we can see here, C2, we will find the updated centroids. The updated centroid will be here, as we can see, cluster 1 will have A1 and C2, cluster 2 will have A3, B1, B2, B3, and cluster 3 have A2 and C1. Again, we can see we need to find out the centroids. Again, we will find out the centroid, which will be C1 will be 3.3, 9.2, C2 will be 6.5, 5.25, and C3 will be 1.5, 3.5. Again, we will go for iteration, same iterations we will do, and then again we will check. So, we will see that the cluster will not change and it will be stable. So, we can say with these centroids, these are the cluster which is stable. So, cluster 1, A1, C2, cluster 2, A3, B1, B2, B3, cluster 3, A2 and C1. With the centroid, A1 will have 3.9, 3, 9.5, 6.5, 5.25, 1.5, 3.5. This is our stable cluster. So, we will stop here and we will mention this with the centroid, the cluster elements and the centroid. So, this is our K-mean algorithm. Here, I need to tell you the disadvantage as well as we discussed why we need the K-mean. As we can see, if I'll make a graph, okay. If I'll make a graph, what I am saying, if there is an element like these are the items, these are the centroid, and there is something here, okay. I'm talking about the far element, okay. So, I told that we need to make two clusters. So, I will take this one, C1, and this is our C2, which will be made like this. As well, you can see this element will have more distance with C1 in compared to C2. So, we will put it into C2. But there is one problem. As in unit 1, since unit 1 we have been studying about outliers. So, what is happening? We are bound to make the cluster. We are including that element also, which is not exhibiting the same kind of behavior. It is approximately 5 to 10%. Still, we are taking it. So, this is the problem with the K-mean clustering. As we are mentioning that there will be a number of clusters on behalf of distance, doesn't matter how far the distance is, how what will be the value of distance. Either it is 3 or 30, doesn't matter. With whom it is nearer, say Centroid 1 or 2, it will go into that. So, K-mean clustering does not deal with outliers, and that is the biggest disadvantage of K-mean algorithm. I hope you understood the K-mean and clustering. Jai.